All right, good morning, everyone. Today we're going to be talking about OOP, inheritance, and polymorphism. Now, when we talk about inheritance, we're also going to cover a different topic called composition, and we'll talk about the difference between inheritance and composition. Now, why is it important to learn this subject, right? Why is it important for you? Well, as we've seen in the last couple of days when we write OOP, every now and then we see small differences, or we want to create a different class that has a lot of things in common with another class. Well, when those two classes have so much in common, we end up repeating some of the code, right? For example, let's say we've been working a lot with a student class. Well, what if we have a student class and then we also have an honor student? Although those two classes should be separate and they have some functionalities that are separate, they still share a lot of common attributes and a lot of common methods that we don't necessarily need to rewrite from scratch. So the entire purpose of inheritance and polymorphism is to apply the dry principle into OOP, right? We all know the dry principle, which is do not repeat yourself, right? So let's talk a little bit about OOP. Today, we're going to be going over when and why to use inheritance, the child and parent relationship, the super method and how it works, instance versus class methods, which I believe we'll cover that shortly since we already covered it yesterday, multiple inheritance, and then composition versus inheritance. Again, all of these subjects are going to be assessed during assessment 1, which will be happening this weekend and will be released tomorrow afternoon. All right, does anyone have any questions over what we'll be covering today? Okay, if there are no questions, let's go ahead and start going into the first subject. So why would I want to use inheritance, right? And this is obviously a drastic example, but we can see here on the left-hand side, we have this old school phone, right? With the dial that you would just turn to be able to dial numbers. Now, we have phones nowadays that are essentially still just phones, right? They all still have the capability to make phone calls. They all still have the capability to actually take inputs of a number and then make phone calls through some form of phone line. Now, rather back then, it was an actual phone line. Nowadays, we use different technologies to be able to communicate with each other. But in the in the end, they didn't rewrite everything from scratch, right? We know that a phone is a phone. It's just that as it developed and it became newer and it had newer features, it had newer attributes, we just started adding into it. Well, that's how that's how inheritance work. We have a baseline of something that we could apply multiple times into different classes. And then after that, we just start handing it out to the classes that could use it. Here's another example. Oh, and actually, this is going to be talking about polymorphism. So that's inheritance. Before I move on, does anyone have any questions about the concept of inheritance?
Yeah, could you have used inheritance for like the car management manager where you have like cars as the babies of the car manager? Or is that like something different?
Yeah, that's a very good question. So if we all remember back into the assignment of the car manager is supposed to have multiple cars. They're supposed to manage the services of said cars, et cetera, et cetera. I wouldn't say that you could use inheritance because inheritance is right? A car manager can't be part of a car, right? You could have utilized composition where car would have been its own separate class, and then car manager would have been strictly used for keeping track of each individual car instance. And it would utilize composition because that would be a has a, meaning it has a car or has multiple cars living within the class or somewhere in the inventory of the class, but it is not an is a relationship. Does that make sense?
Yeah, the is a has a. Took a second, but I understand.
Okay, perfect. All right, so now when we talk about polymorphism, we're talking about changing up the functionality of a specific method of a class, but we're not necessarily, again, rewriting it from scratch. It's just a couple of differences, right? So again, right now we're currently utilizing Zoom. We're able to see everyone's face. Zoom's a pretty nice platform for this. It's able to let me record. It's able to let me do X, Y, and Z. And then so does Google Meets, right? Google Meets has its own platform for us to be able to talk to each other, to be able to share screen, but it looks a little bit different. It has a different user interface, and so does Skype. Now, all three of these generally achieve the same purpose, but the way they go about achieving the same purpose, the same purpose is different, right? And that's what polymorphism looks like. For example, I have a phone, like we looked at in the previous slide. We have these phones. They can all make phone calls, right? But the process for making a phone call for each one of these phones may be different, right? Especially considering the difference in ages in between all these models. So that's how polymorphism works. It's just essentially taking a behavior and slightly tweaking it to fit your class. Does anyone have any questions over those two topics? Okay, perfect. Doesn't look like there are any questions. So let's go ahead and take a look at some code now. All right, so we already covered why inheritance, and we kind of talked a little bit about the dry principle with inheritance. But what does that look like? Well, we already have a pet class. Well, we've already made a pet class in the past. So let's just recreate a class of a dog. And I'll have you guys walk me through creating that class just to make sure that we're all inside of the OOP mindset. So how do I create a class for a dog?
Class and dog, and then colon.
Nice. All right. So now I have my class for a dog, but it needs an init method. How can I make my init method? And what attributes should this init method have?
You
Def.
would
__init __ parentheses self, and then breed and color.
Okay, we'll just
Maybe
go ahead.
maybe age as well.
Okay, age, perfect. And then how do I give, right now, my initializer takes in these arguments, but they're not attributes of the instance just yet. How do I turn them into attributes of that instance?
self dot breed equals breed, and then similar for color and age.
Okay, perfect. And I just realized we don't have a name. What kind of dog doesn't have a name? We need to give him a name. Okay, so now we have our 4 attributes that we're also taking in as arguments inside of our initializer. And we have our class of dog. Great. Well, what kind of methods or behaviors does a dog have?
Bark.
Okay, let's say bark. What should this take as an argument?
Self?
Self.
Nice. So it takes in self as a parameter because it's referencing to an instance. What else? What should it do?
Print wolf.
All right. Maybe you should do it twice, right? There you go. Woof woof. Okay, what else can this dog do? Or what other behaviors can a dog do?
Run.
Sit.
Fetch.
Yeah, it can fetch, it can run, it can sit. Mine sleeps a ridiculous amount of the day. So let's say sleep. So
Rip up trash.
rip up trash. Yes, they do. Let's just say self dot name is sleeping. And then I think we said a variety of things, but let's just say play. Self and print. Oh. is playing with their bone. Okay. So now we have play, sleep, bark. We have all of these methods that belong to an instance of a dog, right? So here we have our methods, here we have our attributes, and all of them are part of a dog class. Now we can see that none of these attributes are privatized, and that's okay. We don't necessarily need to create getters and setters for a breed, a color, or an age, especially because I don't think a breed or a color would change. The age might change, but we could definitely handle that on our own rather than creating getters and setters. Actually, let's at least create one getter and setter, and let's do it for age. Just to make sure that we get some rinse and repeat practice. How do I make a getter for the attribute of age?
At property,
At property.
Okay.
and then get age, get underscore age. Self. And then return self dot underscore age.
And now how do I create the setter for this get age?
Def get age setter. Dot setter.
So you're saying DEF get age dot setter?
Yes.
Okay.
I
I
think
think
that
that
goes above it.
Oh, I'm sorry. At.
Got it. So add. Okay. So now we have our setter being initialized, but how do I create the setter itself?
You would say def set age self and then a self comma new age. Yeah, and then if age is or if new age is greater than age.
I don't think we have an age anywhere
Oh,
except for the initializer. But we don't have access to it here. Are you talking about self dot underscore age?
yes.
Okay.
Then new age. Or I'm sorry, self dot underscore age equals new age.
Okay, so now we have our get age, which is acting as a setter, and we have set age here, takes in self and it takes in new age. And all we're simply asking as a condition is the new age greater than the age that we currently have? Because we obviously can't go backwards. And I guess we should probably make sure that it's less than 100, right? And new age, well, unfortunately, they don't live that long, so let's just say less than 20. Then we could give them a new age. Okay, fantastic. So now we have all of our classes. We have some attributes. We have some getters and setters. We have some methods. Okay, great. So now we created this class of a dog, right? Well, now then the next question comes. What if I wanted a class of a cat? What would that look like? Can anybody walk me through creating a cat?
Class cat colon. And then do the init.
So
with
class
cat,
yeah, init.
self, and then name, age, breed, clause, equals true.
Okay, we're gonna assume they all have claws, all right? And then maybe color as well, right?
Yeah, sure.
Couldn't we just copy like the dog class and then just change some?
Okay, yeah, so you're saying it could be possibly like the dog class, right? So let me just copy this here. Let's paste that there. Okay, so we have the name, we have the breed, we have the color, we have an age. What about claws? What would that look like?
Self dot clause equals true or equals clause, sorry.
No problem at all. And then do we want to have a getter and a setter for claws?
Sure.
I mean, we don't have to if we don't want to. It's a question. It's a question, yeah. Do we want it or do we not want it?
I mean, that would potentially change at an animal shelter.
Okay. So let's give it claws here. And let's go on for creating that getter and setter. What would that look like?
Property def get clause, get underscore clause self colon return self dot underscore clause, and then at get underscore clause self and has clause.
Has clause? What do you mean has clause?
As the other parameter. Oh, sorry, no, that's wrong. It's get clause dot set setter.
Got it.
And then def set clause self, and then has clause or and then I guess if self dot underscore clause equals true, has clause equals false, oh, I was thinking has clause equals false as a value, but that's probably better because you couldn't really give them clause.
Has clause would be what gets passed in, right? Because what this would essentially look like is like this. This would essentially look like I don't know. I can't think of any cat names. Is there any cat names that you guys know? Garfield? Yeah.
Boats.
Socks.
Fox? That's a cat.
Pants.
Jesus. Okay, so then Garfield would set clause. And then that would equal to a Boolean, right? Which would be either true or it could be false. So this is what it would look like, right? And the argument of has clause would be what comes in after the equal sign. So what logic is it that you want to implement here?
Well, I was thinking just if the self clause is true, colon, then has clause equals false. And then self underscore clause equals has clause. But that was just a thought.
I see. Okay. Let's try to do it this way. Let's try to say if is instance of has clause and bool. So if it is a Boolean variable, then self dot underscore clause is equal to has clause. Right, so we make sure that it's a Boolean variable that we're intaking, so it's either going to be true or false, and then afterwards we set that to the fact that the cat has clause. Okay. So now let's see. Now we have our getter, we have our setter. Well, a cat doesn't bark. What does a cat do? Purrs,
Yeah.
right? Okay, so meows. And I'm not sure what I would put here. I guess I would put meow. Okay. They do sleep and they don't play with the bone, but instead they play with what?
String.
Okay, so playing with their bone, instead they're playing with their string. String ball, I'm assuming. Okay, so there you go. So now we have two classes, right? And both of these classes have getters and setters. So let's take a look here. So here we have our dog class. Here we have our cat class. Oh, that's a little different. They each have their own properties, right? With the difference of a dog not being able to be declawed, but a cat can be declawed. We can see that in self.clause. That's a different attribute. And then here we have a difference again, where the dog has getters and setters for age. So thus the cat, but the cat also has getters and setters for clause. And then we can see the methods happening down there. Now, what's the problem with this code, right? If I'm looking at this for face value, I'm looking at the cat file and I'm looking at the dog file. What's the problem here? What principle am I not following?
Dry.
I'm not following the dry principle, right? I'm definitely repeating myself. We can see that the same, almost exactly the same code was copied and pasted in two different files, right? And we quite literally saw me highlight the code, copy it, and then go over and paste it. So now, if I'm not following the dry principle, and let's say I make a mistake in one of these files, right? But I'm so far deep into my program that by the time I notice that mistake, it's almost impossible for me to go back, backtrack, and try to figure out where that mistake is coming from, right? So now this is where inheritance comes in. We have a dog and we have a cat, and they have a lot of things in common. Well, if I know they have a lot of things in common, I can just simply make another class that would be considered a pet that both of these dogs and cats can inherit from. So let's do that. Let's make a new file and let's call this the pet class. Okay. And seems like the pet class, let's just concentrate on attributes for now. Let's bring that over here. And let's turn this into the pet class. Okay, so now we see the class of dog takes in all of these attributes, right? Which are the same exact attributes that we have here for pet. And it has the same getters and setters. Okay. So now that's great. I have this information. But how does it work, right? How do I actually inherit? How do I make a dog not have this repeated code so that I don't have to worry about it? Well, first of all, this file of dog py does not have access to the class of pet because it's not imported. So let's work through the import statement. How could I import the class of pet into the file of dog.py? Can anybody walk me through that?
It would just be from pet, import capital pet.
Perfect. Yeah, so there we go. Now we have pet, right? Well, we know that a function can take in parameters. Right? And since we know that a function can take in parameters, and this is what it looks like, if I'm trying to use inheritance through a class, well, I'm just going to treat that parent class kind of as the argument of what I want. So here I would have pet. Right? So we have class of dog, which is a child of a pet. Okay, well, what does that mean now? Right? Now that I have this information, how is this stopping me from having all of this repeated code? Well, what I'm going to do is I'm going to comment out all of this information here. No longer applies to me. Doesn't matter, right? Well, why doesn't it matter? I could simply put a pass here, and that would take care of my red squiggly down there. But now that I commented all of this out, technically none of this code exists within the dog class, right? Because it's inheriting it from pet. But it's not applied yet. It's not being initialized. Well, this is where we're going to talk about a method called super. So now that I want to initialize this class, I want to call the init method. So super is a shortcut that's supposed to be in reference to any of the parent classes. So I can say super, which is the same thing as saying pet. I can call the init method from pet, and I could just simply pass the same arguments, which we have here. All right, we're going to pass name, age, color, etc. Okay, we just covered quite a bit of ground, and it's all been code. We haven't been able to practice any of it yet because we haven't touched the runner. But before we go into the runner, I want to make sure that I answer any questions anyone may have, especially since we've been going for about 20 minutes and I haven't heard much from the class. So does anyone have any questions over anything that I've just covered? Is there anything anybody would like to see or anything anyone would like some clarification on? Go ahead.
So for what is it? Super.
Mhm.
Would you still need the definite in the dog class, or would that be just, or would that stand alone by itself within the dog class?
Yeah, it's a really good question. So correct me if I'm wrong, but what essentially you're asking me is, we have an init method that's being triggered here for the dog class, right? And essentially we're calling that same init method, but we're calling it through super on line 8, right? And why and do we need both? That's what you're asking me, correct?
Yes.
Okay, perfect. Yeah, so to answer your question, we do need both. And the reason why we need both is because these are two separate initializers, right? Line 7 is initializing my dog class, and line 8 is initializing my pet class. Now, although they take the same exact arguments, right? Think of line 8 as the child of the initializer for my dog. Now, because it's the child, it needs to have access to these parameters, right? And since it needs to have access to those parameters need to be passed to the parent of the initializer. And that's why we see a copy and paste of those two. Does that answer your question, Frank? Okay, fantastic. Clarice?
My question may be slightly unrelated, but I was wondering for the getters and setters, if you're initializing a new instance, do those apply to that or only when you're updating the instance?
When I first do it, I see. So you're saying as far as like data, when I first make my instance, right? Do my getters and
Yeah.
setters matter? They do not, right? They only matter until I start going to trying to change the value. The initializer doesn't have any sort of control. As we can see, the getters and setters are below, right? That means that they don't exist until an actual instance is created of that class. If I had any control variables, they would be applied up here and not in getters and setters down there. Which as of right now, as far as I know, Python does not have a way to control the input for the init method. Does that answer your question, Clarice?
Yeah.
Okay, perfect. John?
Let's say your superclass is in a different folder. How do you import that?
If it was in a different folder, that's a good question. Let's go ahead and do that. Let's go ahead and do an animals folder. All right, and then we move our cat and we move our dog. Okay, so animals is inside of a nested folder, and here's pet, all right? And I don't want to open up too many files here. Can everyone still see this clearly? Like, is there not too much noise on the screen? Are we all tracking what's going on? Okay, perfect. So now, if I wanted to import pet, I would have to say from. It's a good question. How would I utilize dot notation for this one?
Could you copy the relative path?
So when it comes to Python, it doesn't work off of what's it called? It doesn't work off of a path like it would in JavaScript, right? And in JavaScript, it actually takes in a path. So I could do something like PWD, and then I could just copy this path and paste it on there. And technically that would work. But in Python, it works through something called dot notation. And the dot notation pays attention to what it references to as a module. But by module, we're actually talking about a directory, right? So here we can see that animals is a directory, or it's its own module. And we can see that pet lives outside of that directory. Now, when you do this from statement, it's going to look at the top level first. So it's looking at the top level, right? So it's looking at animals, family, pet, and runner. So if I comment this out and I say from, I can see that I have the family file, and we can see these brackets next to it. That's what it's telling me, that it's a file when I do that, right? I can also take a look at runner, and I can take a look at pet. Well, pet is this file, and now I can import the actual class of pet. But let's say we were talking about it in reverse, right? So if we were talking about it in reverse, and I wanted to import dog, and this is purely for import examples. This isn't actually this isn't something that we would actually do, because we wouldn't want to import dog into pet, right? This is just purely an example to demonstrate how to do imports. Let's say I wanted to import the class of dog into the pet file. Well, I would say from, and again, it's going to look at the top level. So at the top level, we have animals, right? I would have to specify which file from there. So I would say dog, and then I could say import dog, utilizing dot notation. Does that answer your question? I think that was John.
Yes. So you can also like what if it's also outside of the folder that you're in right now? So you also type out the inheritance dot animals dot dog.
I'm sorry, I don't think I've
Is
seen
that?
So you're saying like if it's even another level up,
Yes, right.
well then at that point it would be outside of your module, so it wouldn't work.
Okay. Okay.
It needs
No,
to
I
be
see.
within
Thank
the
you.
module in order to import. Okay, perfect. All right. Any other questions? Go ahead, Andrew.
Oh, sorry.
Yeah. So do you not need getters for all your attributes? I thought that was something you had to have for all your attributes.
Getters and setters should be utilized for attributes that you actually want to have control over, right? Meaning that you want to restrict your user from being able to change those values directly. And there's a specific standard that people have to follow to be able to change those attributes. That's where getters and setters come in. All right, so you don't need it for every single attribute. You could just, it may be that none of them need it, but just the ones that actually need a change. Sorry, are you trying to say something?
Yeah, I mean, my understanding was that you needed a setter if you wanted to change something, but otherwise you did need a getter.
Got it. You definitely do not need getters and setters for everything, only for privatized variables.
Got it. Okay, thank you.
Of course.
Then I was just wondering, do the getters and setters come to the child class automatically when you use the super method?
Yeah, that's a great question. So the question was, do getters and setters actually move over, right? And let me comment this out so that it doesn't cause a circular import. So now I commented all this code out. And the reason why I commented all this code out is because I don't need it anymore. I'm essentially copying and pasting the entirety of the pet class onto my dog class. So now dog, whenever I go to initialize it, it's also going to have the get age property, and it's also going to have the set age setter. Does that answer your question, Anna?
Yes, thank you.
Okay, perfect. All right. Look at that. We're in perfect timing. Let's go ahead and take a look at how this works. What would this look like? All right, let's go into the runner. And from the runner, we're going to go ahead and import the dog class. So let's go ahead and say from animals.dog, import dog. Okay. So now let's just say Apollo again. And let me grab that initializer just so that I can remember the arguments and I don't miss something. Okay, so Apollo is a dog. So there's myself. Let's see what it takes in. It takes in a name. So for name, I'm going to give it Apollo. Takes in a breed. Let's just say GSD. What else does it take? Takes in a color. So let's say gold. And it takes in an age. And for age, let's say 3. Okay. So now Apollo exists. Let's go ahead and print Apollo real quick. Now, when I print Apollo, what do we expect to see on my terminal?
Then we
I
have to
think
set the string for thunder method to see anything.
Okay, yeah, I would have to set a string dunder method to see anything, right? So let's see. Now that dunder method. Let's go with the memory space for now. And then we'll talk about the dunder method and how it works with inheritance here shortly. So right now, when I run the runner, we'll actually see just the memory space, right? We'll see that a class of dog was created. So here it tells me, hey, there's in the directory of animals, in the file of dog, there is a class named dog. We created an object of that class, and it's located in the following memory space, right? Okay, so that's great. It tells me that it works. I'm able to know who Apollo is. Well, now let me take a look at the name. Okay, well, the name is there. So even though my dog class doesn't have a self.name, it knows that there is a name because it's able to grab this through inheritance, right? It was able to grab all of these attributes through inheritance. And then the question came along of, well, what about the properties and the setters? How does that work? Well, let's take a look here. If I'm able to utilize get age and I run this, we can see that the get age function works, right? Or getter works. Maybe we could give Apollo a new age. And let's give him an age of 4. And then let's print Apollo.getAge. Well, now when I run this, we see the original print statement, which has the original value that I gave Apollo for an age. And then when I run it on line 7, we can see that its value was changed to 4 because the set age attribute kicked into place, right? So although this code doesn't exist in here, it's being inherited through the pet class. And that's all in here. And that's inheritance in a nutshell, being applied to at least one class. Does anyone have any questions about that? Go ahead, Eric.
I guess this is more for like structuring your files later on, but if we're gonna have a class with a lot of child and like a parent class with a lot of child classes, do we want to organize it like how you kind of did in the animals directory with like a cat, dog, just to kind of keep them separate, or
Yeah,
just so we don't one big thing of code?
Yeah, that's definitely a good question. And honestly, I would recommend to try to isolate everything as much as possible. Just for the reasoning of being able to read things, right? Because just like you mentioned, if I had all of these files all jumbled up and then I had a pet and a family and a cat and a dog, another Python developer could look at this and say, well, I have no idea what's going on here, right? So now if I start dividing my files into directories, well, then another developer can look at it and say, oh, I see. Well, he has this animals, they're inheriting from pet, and pet has a hierarchy And then because I don't have pet nested within the animals folder, it can also tell a developer, oh, that's supposed to be the parent, and these are the children of that class. Does that make sense?
Yes, it does. Thank you.
Of course. Clarice?
For like separating this specific class, if we added like legs, would we just, or for the dog class, would we just make that a self.age under the super init, or
Oh, yeah, that's
it's
a
not
great
inherited? Yeah.
Yeah, that's a fantastic question. Let's go into that. I'm gonna save that question because I'm actually about to demonstrate it once we go into cats. Any other questions? Okay, fantastic. So now we went over how to do inheritance with our dog, but now how do we do inheritance with our cat? Let's take a look at the cat file. And let me clean this work area up a little bit. Okay, so here we see our pet. It has getters and setters. So let's take out the repetitive code, right? We know that we have name, breed, color, and age. So here we go, name, breed, color, and age. All of that is repetitive. We have this get age property, and we have the get age setter. So both of these are also repetitive. So now we can comment them out. So now we have these attributes, right, that are being shared between them. Well, just like we did in the dog class, we could use the super. So here we do, oh, and actually before we do that, we probably want to import. So I'm going to say from pet, import pet. I'm going to utilize the super method to call the init method. And I'm just going to pass in the same thing. So I'm going to pass in the name, the breed, the color, and age. Now notice, just like Clarice just asked, we also have this clause argument or this clause attribute. It's not it's not part of my pet, and it's unique to only the cat. So that's where I would actually just leave it on line 11, right? Line 11 would then show after the init method. So the init method treats everything that's repetitive and that I could inherit, but anything that's unique to the cat would stay on the cat class. I still have self.clause. I still have a get and a setter for clause, and it still has its own methods as of now, right? So now if we go to the runner and I go and create a cat. So let's say, I think we went with Garfield, or I went with Garfield, but honestly, Socks. Socks sounds pretty good. Go ahead, Anna.
Don't we need to put pet as an argument for cat to import that?
Yeah, good catch. Thank you. I really appreciate it. That was a syntax error on my part, right? Otherwise, the super method would have no idea what it's looking at. So yeah, that's great. And let me actually import cat from over here. Okay, so now here's our cat method. What does our cat need? Well, our cat needs a name. His name is Socks. It needs an age. I'm gonna go with 3 again. It needs a breed. I don't know anything about cats. Can somebody give me a breed?
Tuxedo.
Abby. Oh,
Abby? Is that right? Am I spelling it?
Tabby with
Okay.
a T. Tabby.
Yeah, with a T.
Someone spell it out for me.
Abby with a T.
With the T, where would the T go? Is it AT?
T. It's
Tabby. Like you gotta pay your tabby at the bar.
I kept hearing Abby. All right, Tabby. And now we have the breed. What color do we like on there? Orange it is. And then clause, we have it defaulted to true, but let's say they've been declawed, so let's make it false. Okay, well now when I go to print socks, we're going to see that memory space one more time. Oh, we don't want that. All right, so now we see, hey, there's a directory of animals that has a file of cat. This file has a class named cat, and we created an instance of that, and we are saving it in the following memory space. Okay, perfect. Well, what if I want to see the name? And I run it this way, the name works. Well, what about get age, right? Because that's the other thing that we have. We have inheritance through our getters and setters. Okay, well now socks dot set age, and let's make it 5 this time, and let's print socks get age. Well, now we can see how everything works, right? We're able to see that the age was 3. We changed the age utilizing our setter. And then when we print it again, we see that the age is now 5. And that's inheritance with attributes. Does anyone have any questions over what I just covered? Did that answer your question, Clarice, from earlier?
Yes.
Okay, perfect.
What if you wanted to like change, can you change a method from the parent class? Like could you edit it or overwrite it?
Yeah, that's a really good question. And now we're going to be talking about polymorphism.
Okay, sorry.
No problem at all. And we'll just switch these 2 points here. We'll switch composition versus inheritance later on, and then we'll talk about polymorphism now. Okay, so now we have our pet, we have all our classes. Let me close all of these files so that we can get some clear workspace here. Okay, let me open up the pet, I'm open up the cat, and I'm open up the dog. All right, so our dog has the ability to bark, has the ability to sleep, and it has the ability to play. And our cat also has the ability to sleep, and it has the ability to play. Now, both of these methods are almost exactly the same, except that when a cat plays, it plays with a string ball. And when a dog plays, it plays with a bone. So how do I change these up? And how do I utilize inheritance? Well, I know this one's the same, right? So since this one's the same, I can just, oh, hello. I can copy it. I can bring it over to my pet class. And I can give it the same method, right? So now I know that both my cat and my dog are able to sleep, and that's happening through inheritance. Now, both of them can play, right? But they may not necessarily play with the same argument or with the same thing. So let's go ahead and do some polymorphism in there. We're going to comment it out for now. And let's go into pet. Well, here we can say play self, and we can say print. We can make this into an F string, and we can say self.name is playing. We're not necessarily saying what they're playing with, but we're just saying that they're playing, right? If I take a look at my runner now, and I try to have socks play, is that a print statement? I think that is a print statement. And then try to have socks play, we can see that socks is playing. That's all we get. We don't know what they're playing with. That's all we get. Well, here is inheritance happening, right? And I'm getting the method correctly, but I want that method to have a little bit of a different behavior. Well, I can go to cat and I can overwrite that method. I can still give it a play method. It's still named play, but now instead of saying, hey, the name of this animal is playing, it's saying they are playing with their ball string or with their string ball. And now when I run the runner, instead of saying sock is playing, it's saying sock is playing with their string ball. And it has a little exclamation mark. And that's polymorphism, right? It took the method that was passed into it, right? Because we did pass the method of play, and we passed it into the cat class. So it took the method, but after it took the method, it said, you know what, this isn't fitting exactly the needs that I want. So I'm going to change it a little bit. I'm going to make it do this. I'm going to make it not only say that it's playing, but it's playing with their ball of string. Right? And the same can be done with the dog. Dog is also inheriting that method. If we take a look at the runner, and I uncomment this information for dog, except for this, maybe. Probably don't need that. And I say Apollo.play. We see Apollo is playing, right? And if I take a look at the dog class and I scroll down, currently right now, I'm not utilizing polymorphism. I'm only utilizing inheritance, right? And that's why I see Apollo is playing. Now, if I want to utilize polymorphism, I just simply rewrite the method. I still call the same method. I utilize self, but I give it a different behavior. And now when I run it, it's saying Apollo is playing with their bone and Socks is playing with their string ball. That's polymorphism. Does that answer your question? I think that was Joshua. Okay, I see a thumbs up. Perfect. All right. Does anyone have any questions about polymorphism?
And you can still call super in those methods if you still wanted to call the original code.
Oh, like within here, if I wanted, like if I have something nested and I went super and then yeah, I could call play. Is this what you mean?
Yeah.
Yeah, I could still do that. So if I do that, we can see Apollo is playing, right? Which is triggered through the super method here on line 31. And then I see the print statement of Apollo is playing with their bone. Awesome. Okay, so now we talked about polymorphism and we've talked about how inheritance work. The next thing that I want to talk about is going to be called abstract methods. So now, abstract methods are methods that don't have any behavior, but they ensure that the methods exist within any class that are children, right? So here we have our pet class, we have our dog, and we have our cat. While our dog is able to bark, while our cat is able to meow. Now, to me, that just sounds like I'm telling my dog to speak, or I'm telling my cat to speak, right? So now let's take a look at what the abstract method would look like. So here I'm going to have to import something called ABC. This comes built in with Python. It's just a Python library. And I'm going to grab ABC and abstract method. Now, notice how ABC is highlighted in green, just like pet is. What does that tell me?
It's a class.
Yeah, it's a class. It's a class that has functionalities included in it, right? So now I'm just simply going to give pet ABC as a parent. I don't have to worry about a super in it or anything like that. I'm just giving it extra functionality so that the pet class can actually hold abstract methods within it. Does anyone have any questions about that so far? Okay, so now I'm simply just going to make my abstract method now. I'm going to say, just like before with decorators, I'm going to say abstract method. And I'm going to give it the speak. This speak is going to take in self. And all it's going to do is it's going to do absolutely nothing. It's going to say pass. Now, what's going to happen when I run this Python script now? Well, when I run this Python script now, and it stops immediately at line 5 when I'm trying to initialize a dog. And it says, hey, we can't make this actual class because it's missing an abstract method of speak. So notice I did speak here, right? And it's utilizing inheritance, so it's not like it's missing it. But what it's actually telling me as a developer is it's saying, hey, this isn't a specific requirement, or this doesn't have any behavior that you can rinse and repeat. But we want to make sure that any child of this class has this method. So all I'm going to do is I'm going to change this spark to speak. And I'm going to change this meows to speak. And now when I run my runner, everything works fine. Everything's working well. Well, all I'm doing again through the pet class by creating this abstract method is I'm just essentially creating a rule. And this rule says that any child that inherits from the class of pet will have a method named speak. So now I went to my dog class. I have a method named speak where it says woof woof. I have a cat with the method of speak where it meows twice. And now if I go to clear my terminal and I go over to my runner and I trigger both of those, let me go ahead and comment out this play arguments. Let's say socks.speak and apollo.speak. So here we see woof woof and the meows. Perfect. And that is it for abstract methods. All right, again, it's just a rule. It's nothing crazy. It's just saying, hey, any other class that inherits from me will have this method. I'm not going to tell it how to apply this method, but it will have this method. Okay, the last thing that we need to cover today is going to be composition, but I'm going to save that until after the exercise after the morning exercise. Go ahead, Josh.
Yeah, so ABC and abstract method, that's just coming from like, the Python program.
Yep, all of this is just coming straight from Python.
All right.
Any other questions? Okay, fantastic. Let me go ahead and stop the recording at this point, and then we'll break off into some exercises. All right, welcome back, everyone. So let's do a little quick review over abstract methods, and then after that, we'll go over composition versus inheritance. So again, an abstract method is just essentially a rule or a regulation saying that any class that inherits from this parent class of pet will have an abstract method of speak, right? It's not the same as polymorphism. Polymorphism is where I create a method and that method is overwritten in another class. In this case, an abstract method is just I create a method that's a rule. I'm saying every single class that grabs from this, that inherits from this class, will have a method named speak. I don't know what that method's going to look like. I don't know what that method does, but I know that it is a necessity for every class. Does that answer your question from earlier? I think that was Matt.
Yes, that answers it. Thank you.
Of course.
So wait, I guess so.
Oh, go ahead.
Actually, never mind. If it comes back to me, I have like another question, but I just lost it. I don't know. I'll ask it if it comes back.
Okay.
Yes, I kind of have a question.
Yeah, go ahead, Clarice.
So what exactly is the use case? It doesn't really seem to force the other classes to make a speak function. So I'm like, what is this?
Yeah,
what does it do? Yeah.
Yeah, it definitely does force the other classes to make a speak function. So as you can see here on line 31, we have the speak for the cat, and then we have speak for dog, right? If I were to take off the speak for dog, or let's say I turn it into bark, and let me go to my runner, let me comment that out. And I try to run my runner now, it's going to tell me that it can't be initialized. It's going to tell me, hey, we can't create this class because according to the abstract class that you have here, you're missing the method speak. It's not registered. It doesn't exist. So now if I turn this into speak, now I'm following the rules and now it's able to run my script just fine. So that's the use case for it. I'm providing a rule set. I'm saying, hey, anything that inherits from this class will have this method. Does that answer your question, Clarice?
I think so. Somehow I was able to make it not throw an error. So I don't know. I don't know what I did.
Okay. I would probably have to take a look at that personally. Joshua?
So it only cares that you define it. It doesn't care what's inside of it. Is that why it's called abstract?
Exactly. It only cares that every class carries it, but it does not care about what's the content of it.
Do you know like a practical example where that like is the case over like polymorphism? Because like they seem very similar. Where it's like I don't care how it's done, it just needs to be done. Like I guess what's the main difference, or where do you see the main case that people use one over the other?
Okay, so if I were to think of like a real life example, right? And let's say we're talking about two different cars. One's electric and one's gas, right? They both need to have a way to start the car, right? But the logic within starting the car could be completely different, right? Where an electric car would utilize electricity, would have different functionality, would have different attributes going into effect. Maybe it has some other nested methods going into effect. And same thing with a gas vehicle. A gas vehicle would have a completely different startup system than the other, right? Now, you may think, well, polymorphism does the same thing, right? Polymorphism, you can tweak the functionality, but the difference is tweaking and completely different, right? Tweaking the functionality, that's where polymorphism comes in. It's just a small change. It still follows the inherited rules, or it still follows kind of the same baseline, but I'm tweaking it just a bit to be able to meet the requirements that I need. Whereas abstract methods these are completely different functionalities, but they both need to have the function within it. Does that make sense?
Yeah, it's getting there a little better. Thank you.
Of course.
And it seems like, I guess, abstract would, the benefit of it is it won't let you forget to add that method because it'll throw an error. Like it's like, so you can't just run that class because it's going to be like, hey, you forgot to add this method. So it's like checking you.
Exactly. Yeah, it also provides that like backbone of a rule set, right? Because it's saying, hey, these have to be completely different in every class. But at the same time, every class does need to have it. So because every class does need to have it, I can't let you make a class instance without having this method.
So I guess what Clarice and I, what we ran into was like it was still working even though we only had it defined. So I guess my question is, will it throw it if you try to use it or if you just run the file? Like if we didn't define speak in dog, but it was defined in like animal, and then we never tried to do like, dog object dot speak, would our file run and execute with no error even though it's not implemented in dog since we didn't try to run it?
Got it. So this is the dog class. I currently commented out speak. Here's our pet. It shows that we need speak. And here's our runner class. Nowhere in the file is speak being ran, right? When I run this file, I get an error because it's simply telling me you can't do that. You can't create a dog class that inherits from pet without having the speak method. I can create the speak method and I can put pass, right? And have no functionality within it. And now it runs. It runs without throwing an error now. And the reason why it runs without throwing an error is because now the method actually exists, right? Does that answer your question?
Yeah, and then you just define it as an abstract method at like the highest level of the class where you want it to like start being, assuming.
Right. Parent is the one that holds the abstract method. Sorry, Siri's trying to
Okay, I found this on the web for read the.
Sorry about that. All right. Where was I? The parent is the one that holds the abstract method, not the children.
Okay, all right. Thank you.
Of course, no problem. Any other questions regarding abstract methods?
I have a question. So, when you use the abstract method, it only works for the child, right? Like if you try and do like a grandchild, it wouldn't work.
No, it would definitely work still with the grandchild. So if I have a dog, right, and then later on I create a German Shepherd class and then it inherits everything from dog, by inheriting everything from dog, I'm also inheriting everything from pet, right? So either dog needs to have the speak method, or the grandchild needs to have the speak method. But somewhere upon that child, those children, there needs to be a speak method that gets defined. Does that answer your question, Megan?
I think so.
Okay, perfect. All right. So now the very last thing that we need to cover is going to be composition. So I'm going to close all of these down. I'm going to comment everything out in here. That way we don't have to worry about it. And now we're going to start messing with the family. Now, family is going to be pretty simple. Let's say we have a class of a father, all right? And I don't know, for the init method, just going to go with something, let's say self, job, name. And let's just say, well, I guess the easiest way of doing this would be doing it like this. So let's say class, parent, def, init, self, job, name, and then, oh, hello. We could just make these attributes real quick. So self.job is equal to job. Self.name is equal to name. And then that way a father can just parent, and we can just call the super method. Okay.
Hey, Francisco, question.
Yeah, go ahead.
Since you're already putting parent or father parentheses parent, do you have to put the initializer since it's already pulling from parent?
You do, yes. Because you're still needing to call the function itself, right? So remember, the initializer is still a method, right? So this one will get called automatically whenever I try to create an instance. But the one from my parent will not be called automatically. I need to trigger that manually. And that's why I call it through the super method. Does that answer your question?
Okay. Yes.
Okay, perfect. Okay, and then super dot init, and then job, comma name. Okay, so currently right now, I have a parent class, right? And this parent class can take in a job and a name. And we see these two attributes. And then I have a father and a mother, all right? And we have these two parent classes. Okay, so this is a pretty good example of inheritance, right? This is a example. A father is a parent and a mother is a parent, right? And this is how the relationship of inheritance happens. But now let's talk about composition. So now we're going to create a child. It's not going to inherit anything. And instead, in its initializer, it's going to have a self of a name, a father, and a mother. Right? And then what that initializer could look like is it could be something like self dot name is equal to name, self dot father is equal to father, and self dot mother is equal to mother. And these right here would essentially be an instance of the father class and an instance of the mother class, creating a has a relationship, right? So a child has a father and it has a mother. And that's how that works, right? It's able to say this is a has a relationship rather than an is a relationship, which is what we have over here, where a father is a parent, a mother is a parent, but a child has a father and has a mother, right? So now if we were to go to create these class instances, so we could say, let's go with something generic here. So then we have father, and then the name is John. The job is, I don't know, SE. And I think those are the only two arguments it takes, but I have those backwards. And I'm not sure what name to go with, so I'm just going to go with Mary. Okay, so now we can see John and Mary. There's a father and a mother, right? Well, when we go to create a child, I don't know, Billy. Well, the child would have a name, which is Billy. And then for a father, it would take in John. And for a mother, it would take in Mary. Now, when I run to this, when I go to run this Python script, if I say Python family.py and I run it, we see there's no errors, and that's telling me something. It's telling me at least my code is working. If I print Billy.name and I run the script, we can see the name of Billy. Well, what if I do Billy.father? When I run that, we see that I get a memory space, and that's an instance, right? It's telling me, hey, in the file of main, which is the family py file, there is a class named father, and we created an object that's saved at 0, whatever memory space that is, right? And I could just say dot name again, because it's still OOP. And now we can see that John appears, right? So here is a has a relationship versus an is a relationship. And that's the difference between inheritance and composition. Does anyone have any questions about that?
I do.
Okay.
I guess what would we use this for?
And so what could you use this for? Let's say you were creating a video store, right? And in that video store, there's videos, right? Well, you would have a class named video store, and that class would manage the entire store, right? It would manage inventory. It would manage, people who can rent out videos, the different type of memberships. It would manage the different type of employees, how many videos can be rented out to each member, X, Y, and Z, right? So that's a class of the video store. But each video could be a class in itself, right? Each video can have a length, which is a specific attribute. They can have other things that are specific attributes that apply to it. And maybe they have specific methods, right? Maybe some of them are special editions or extended editions, who knows, right? Each video could then represent its own class. Well, now you have a class for a video store, and then you have a class for a video, right? Well, when I go into my video store and I create the attribute of inventory, what would be the attribute of inventory? What would go inside of the inventory of a video store? That was an actual question.
Like videos?
Yeah, a video, right? So
food and something else.
Yeah, perfect. So then at that point, I would have has a relationship, right? My video store has a inventory of videos, not is a video, but it has a series of videos within it. Whereas I could have a video be a class, right? But then I could have a class of rated R or PG-13, et cetera, right? Which are the different varieties of videos, but they're all still videos. So at that point, I would use inheritance, because even though I have a tape that's rated R, it is still a video, right? So that's an is a relationship versus a has a relationship. Does that make more sense?
Yes.
Awesome. All right, and then I saw someone else raise their hand.
That answered it. Thank you.
Oh, okay, perfect. Does anyone else have any questions about the difference between composition and inheritance? Okay. So no one asked this question, but I just want to make sure that it's clear to everyone. You cannot use polymorphism through composition, right? It is not an is a relationship. So I can't change the method of another object through this class. So I just want to make that clear. This is composition. It's a has a. I can't use polymorphism in this case. All right. Okay, so it looks like I believe those are all the subjects for today. We covered everything. So today in overview, we went over why inheritance. We went over how to apply the do not repeat yourself concept with inheritance. We went over polymorphism and how it works with inheritance. We talked about composition, which is what kind of relationship?
The has a.
Which is a has a relationship, and inheritance, which is what?
Is a.
And is a relationship. Awesome. And then we talked about abstract methods, which are essentially just rule sets saying, hey, any other class that inherits from this parent will have this method. Awesome. So polymorphism is slight change, whereas abstract methods are completely different methods. Okay, awesome. At this point, this will conclude our lecture. In overview, today we covered why inheritance, how to apply the do not repeat yourself concept, polymorphism, composition and inheritance, and abstract methods. I am more than confident in everyone's abilities to put these concepts into practice in today's assignments, and that all of you will pass your assessment this weekend. Does anyone have any closing questions before we conclude our lecture?
I've got a quick one, Francisco.
Yeah, let's hear it.
So in your previous example, it shows the memory space for the father. If you use a dunder string method, would you have to put that in the father class, or would you, I guess, call that from the child?
I think you're talking about in here, right? Would I call it from the parent or the father, right? That's what you're asking?
Yeah, if like your previous example, you used the child. So Billy's father, when you did that, it showed the memory space. How would you get that to show all of the father's attributes?
Yeah, that's a very good question. So if I wanted to see everything from the father, right? And I'm assuming we would want the same behavior for the mother. Well, I would just create my dunder method at the parent level. And I think you asked me this question earlier, and I apologize for not addressing it until now. So I could just say self, right? And I could have this statement say return an F string, and this could be self.name, works as a, and then here we could have a self.job. Right, so now when I go to print this, instead of specifying the name, I could just say billy.father. And when I run it, we get the string method, or the dunder string method, coming all the way from the parent class, saying John works as an SE, right? It wasn't specified in the child of the parent class, which is father, because it just used inheritance. It was able to utilize inheritance to grab this dunder method, and then utilizing composition, I still have that method available. So when I call billy.father, it's able to trigger that dunder method. Kind of like a daisy chain, just trickled all the way down. Does that answer your question, Sean?
Yep, thank you.
Of course. Any other questions? If we have what ifs, this would be the time to ask those as well.
How about if you wanted to print out that Billy has a father, or Billy's father is John?
If I wanted to print out what?
If you wanted to print out Billy's father is John, would you put that dunder method in class? But like, how would you?
Yeah, so then
What would you call his father?
yeah, in that case, that would be something that applies to Billy, right? So I would say EF str. I could take in self. Then I could say return an F string. And I could say self dot name is the child of self dot father dot name and self dot mother dot name. And now when I go to print Billy in its own, that's when I would get Billy is the child of John and Mary. Does that answer your question, John?
Thanks. Yeah.
Go ahead, Cody.
So if you had privatized the names of like father and mother, when you call them in the string method under the child, would you need to do a getter, like to get father's name, or would you just still do it the same?
Could you say your question one more time?
So if you privatize like father's name and mother's name under the parent class, yeah, and you like underscored it, out of good practice, would you use a getter in the string sentence for the child?
Yeah, I would essentially want property and then BF get name, fix in self, return name. Oh, I probably want self dot name. And then this would be get name. And this would be get name. And everything still functions correctly. Right?
Thank you.
Of course. Go ahead, Brian.
So just kind of thinking of how to apply this, if we're using our zoo example of like the aviary and the reptile container, kind of the way you were talking about how you would put a video in a video store, if we wanted to use this kind of composition to put birds in an aviary, like how would that kind of start changing our data as opposed to just having a dictionary of birds in a class of aviary?
Well, that is composition, what you just said to me. So for example, we have how can I do this? So let's say we have a daycare, right? And this daycare has a mint method, takes in self, takes in name, and that's it. That's all I need to initialize daycare, right? And in this daycare, I have an attribute of self.name is equal to name. Then I have self.children, which is equal to a list, right? Obviously, I would want this to be a dictionary, but for now, I'm just going to make it into a list for simplicity's sake, right? And see if I can make this rather easy.
Just do the George Foreman. They're all George.
Right.
Or just make 3 children with the same parents.
Oh, look at that. That would be a lot smarter, wouldn't it? Thank you. All right. So now let's make this George. Change that for George. And Allison. Change that for Allison. Okay, so now we have our 3 children. Well, now when I go to make my class, which is my daycare, right? I'm just gonna say, I don't know, daddy daycare is equal to daycare, where the name is daddy daycare. Okay, well now all I would do is say daddy daycare dot children dot append. I would put Billy in there. I'm essentially going to do this multiple times. So here's George. And here's Allison. Okay, and now when I go to print daddy daycare dot children, we're going to see a has a relationship, right? We have a daycare and where we're storing all of my children instances inside of a list. And when I go to print that list, we see a series of memory spaces, right? Which we learned yesterday that if we don't want to see memory spaces, we can use the REPR, which is the representation method. And then we can see Billy is a child of John and Mary, George is a child of John and Mary, and Allison is a child of John and Mary. Does that address your question, Brian?
Yeah, it definitely gives me a starting point. Thank you.
Of course. Any other questions? Okay, thank you so much, everyone. Appreciate it. Let me go ahead and stop the recording. And after I stop the recording, I'll check the calendar.